Welcome to beautiful Wonderland Lake here in Boulder, Colorado. We're here to talk about the effects that climate change will have on water and water supplies in the western United States. Let's talk for a moment about the phrase climate change. Here in this video, we're using that phrase to refer to accelerated warming of the planet that we've seen over the last several decades and that we expect to continue to see into the future, most of which has been caused by man-made emissions of greenhouse gases. Now, climate change has resulted in warming of the entire planet. Here I'm showing you a graph that makes just that point. This graph is showing departures from average of the temperature for the entire planet in every year since the year 1900. This is compared to the average of the entire 20th century. And you can see there's a clear trend of it getting warmer and warmer, where the average temperature tends to be above that 20th century average as you get closer to the present day. Now, as the planet has warmed, so has the western United States. This is the same type of graph, but showing just the southwestern United States. You see the same pattern. There's a clear warming over the last several decades. Here is that same type of graph again for the state of Colorado. And again, you're seeing an increase in temperature. What we did here was we actually included dashed lines that show you that there is a trend of warming over the past 30, 50, and 100 years here in Colorado. What does this mean for water? Well, we'll look at it from both the lenses of water supply, or the water that we have available, and water demand, how much water that we need. Let's talk first about water supply and climate change impacts on water supply. So the most important factor determining how much water supply we have in a given region is precipitation. So precipitation is where our water supply is coming from. And so the amount of precipitation is going to have a strong influence on how much water supply we have available. But that's not the end of the story. Temperature also has a lot to do with this. And temperature, in fact, can increase the amount of evapotranspiration that occurs, which means more snow or water turning into water vapor and not being available as streamflow runoff downstream. And of course, this temperature increase is significant because not only have we experienced it over the last several decades, but we expect to continue to increase it so long as greenhouse gas emissions continue to go up. So we're looking at, by the middle of the century, a much warmer western United States. Now, the actual warming is a range because it depends on things like emission scenarios and the variability of the climate system, but the general trend is hotter. That's just temperature. Precipitation, which again is the most important driver of how much water supply we have, is a bit more complicated to figure out. That's because precipitation itself is very variable, and here in the interior west depends on the vagaries of the motions of storm systems. So it's a little bit harder to figure out, but we can look at what overall trends we're seeing. And when we look at overall trends, we see that we expect that the northern tier of the west is probably going to get a bit wetter, and we expect to see that the southwest and the southern tier of the west is probably going to get a bit drier. Those are general trends we see, and this image you're seeing on the screen is an average of climate model projections showing blue areas where you would expect to see it get wetter and orangish brownish areas where you expect to see it get drier. But that's just the story for the entire annual average of precipitation. What about seasons? We know that seasonality is very important, especially here in the West, where wintertime precipitation in the form of snow in our headwaters regions is really critical to how much water supply we have available. Well, there we start to see trends across the West of generally drier summers and generally wetter winters. This doesn't mean necessarily that we will see that for sure in the future. That doesn't necessarily mean that it will happen everywhere across the West in the future, but it's a general trend that we start to see. All else being equal, wetter winters could be good because that could mean more snowpack. However, we have to remember the temperatures are increasing. And in many parts of the West, warmer temperatures means snow might actually start falling down as rain instead. And that's bad news because in this area, we rely on snowpack to be that critical natural reservoir, holding our water supply and releasing it when we want it to in the spring. So if it falls as rain, we catch a lot less of it, and it's a lot less useful to us in terms of water supply for farms and cities. Timing of water supply is also really critical here in the West. We've discussed that in a number of videos already, and we really want to reinforce it here when we talk about the impacts of climate change. That's because, if nothing else, warmer temperatures means snow melts faster and sooner. And that's another real issue here. We've already seen that in the southwestern United States, snowpacks have melted up to a month faster simply because of the effects of a warmer west. And that's the kind of thing that we expect to happen in the future because temperatures are expected to rise. Earlier snowmelt means earlier peak runoff. That's the time when there's the most water in the stream, and a longer period when we have low flows, or the lowest amount of water in the stream. Both of these are really critical. Peak runoff is when we try to catch water, store it for later use, and low flows are those times when we really need water because there's not much available in our streams naturally. Finally, when we talk about water supply, we want to talk about watershed impacts. I talked to you in a video earlier about how a variety of things such as wildfires and bark beetle infestations can affect water quantity and quality coming out of our islands of moisture here in the West. As temperatures warm, we expect to see both of those things become more frequent and more severe. Warmer temperatures means the likelihood of conditions that are conducive to wildfires increases, and that the conditions that stress trees and makes them more vulnerable to bark beetle infestations are also likely to become more common. So let's look at the other side of the water coin here and talk about water demand for a second. Climate change doesn't just affect how much water supply we have available, it also affects what we need water for and how much water we need. That's water demand. And as temperatures rise, we generally expect to see that we'll need more water for a variety of uses. For example, as temperatures rise and snow melts earlier in the year, we have a longer season when plants and crops will want to take up water in order to grow. That means a longer time when water will be removed from the land surface and transpired back up into the atmosphere instead of turning into runoff, which feeds streams and rivers. Timing is also a critical water demand issue because one of the biggest issues here in the West is making sure that water is available for irrigation of crops and for other uses late in the summer when there's very little available in our streams. And the earlier our peak runoff happens, the more difficult time we may have trying to match up the timing of when our water is available and when it's needed the most. In fact, the whole entire season when water is needed for growing plants and crops may become longer. In addition to just the water demand for plants to grow, we also know that water is often used to cool crops. So this is another element of water demand that's really relevant to agriculture, and that is that in order to keep temperatures lower, ambient temperatures lower around crops, farmers often spray water just to reduce temperature. This is another additional use that will probably increase in the future as farmers strive to keep crops from failing due to high temperatures. In cities, water demand can be a little harder to project because it has a lot to do with human behavior and it has a lot to do with land use. However, we generally would expect that if people keep their lawns the same, we would need more water to water lawns, and people may find more reasons to use water for all kinds of outdoor activities in the summer as we have longer warm seasons. Finally, we have the stress from the variety of different uses of water. We'll talk later on in the course about what we call the energy-water nexus, or the use of water by the energy sector. It's really critical here in the western U.S., where we produce much of our electricity using thermoelectric power plants. Those are plants that boil water and turn it into steam to drive turbines to generate electricity. As water demands go up and as electricity demands go up in order to keep our homes and businesses cool, we will likely see more and more stress on our water supplies as all those things collide. This is a real concern here in the West, as scarce water resources, which we already compete for vigorously, may become more scarce and the demands on them may grow. Now that we've talked about water supply and demand, what are a few other very relevant effects of climate change here in the western United States? Well, one interesting one is actually generation of power from hydroelectric plants. As you know, the West features some of the largest dams in the United States, and within many of these dams are hydroelectric turbines. When reservoir levels drop, less and less water is available to go through these turbines and generate electricity. And under climate change, in many parts of the West, we expect drought to potentially become more frequent and more severe. That could mean more times when water levels in reservoirs go down and less hydroelectricity is available. Higher temperatures across the planet and across the West can also mean warmer water temperatures. And warmer water temperatures can mean other effects on water quality and aquatic habitat. For example, as temperatures rise in our streams, we get more organic matter that is more difficult to remove in water treatment plants. This is also potentially a negative effect on many species of fish that rely on cold water for their habitat. This is also correlated with the level of flow. Lower levels of flow often result in higher temperatures in the summer. And if we have longer periods of low flow, we will potentially see warmer and warmer temperatures in the summer that will affect both water quality and aquatic habitats. Climate change is also tough on a variety of other species especially that lack the ability to move to cooler temperatures and maintain habitats that are suitable to them. Over in the human side of things, a lot of people are very interested in recreation, which is a much larger portion of the Western economy these days. Climate change could have a variety of different effects on it, some potentially positive, some potentially negative. One area that is of particular concern is the industry of rafting, which is very common here in Colorado and elsewhere in the West. When runoff happens faster, there is a shorter period of time when that really fun high water is available for people to raft on and enjoy themselves. Skiing is another interesting question, one that a lot of people ask when it comes to climate change, obviously because skiing relies on snow. In many parts of the West where snowpacks occur in places where it's not necessarily that cold all the time, we potentially could see shorter skiing seasons or more times when snow falls as rain, endangering skiing opportunities. All of these are a variety of new challenges that could occur as the climate warms here in the Western United States. We've done quite a bit, and that's a main theme of this course. We've done quite a bit to move the water that we need across landscapes to be able to survive in these places. And that kind of adaptability could provide us some ability to adapt to the challenges that are going to come with climate change in the future. But we'll probably still see a number of other different vulnerabilities. And this is an active area of research and preparedness right now. So I hope that's provided you with some idea of what climate change might mean for water here in the Western United States. Thanks again for joining us, and I'll see you next time.